Take a look at our most advanced factories. And we built it twice. Before we poured the first concrete, we simulated the plant with a digital twin. We optimized the building, the factory layout, the process flow, and even the manual work. And once the digital twin was perfect, we built the factory in the real world. And we built it faster than ever. Manufacturing capacity is up 200% compared to previous factories, productivity is up 20%, and energy consumption is down by 20%. So, the most critical building blocks of the industrial metaverse are here right now, and they are part of Siemens Accelerator, our open digital business platform. The building blocks are the digital twin, software-defined automation, data, and AI. And now let's take it one by one. What is a digital twin? Let's look at this airplane. You step on board and you want to be safe, you want to be on time, you want to be comfortable. It can take aircraft companies easily 10 years to create a new plane. That's why they use digital twins for the airplane to accelerate design. They accelerate sustainability by using digital twin simulations to reduce fuel consumption. And they accelerate access to new technology with digital tools and AI that makes it easier for their people to design and build. So, the digital twin is the chief building block of the industrial metaverse. And it is not just high-quality 3D rendering like for computer games. The digital twin we build have much more depth. They are physics-based. So what happens when we shake it, heat it, drop it, or change the software configuration? And the digital twin not only looks like the real thing, it behaves like the real thing. And we've been working on this technology for 30 years now. And today, we can give you a high-fidelity virtual representation of, well, anything. Airplanes, yes, but also power grids, factories, complete cities, the products you buy, the Mars rover, or even a beating human heart. And in the industrial metaverse, the interaction will be so immersive, interactive, so lifelike, we will hardly be able to detect whether we are manipulating a physical object or a digital twin of one. We can do it without traditional bounds of time. So when something goes wrong, we can go back to the moment the problem first appeared and fix it, or ask an AI co-pilot to do it for us. We can simulate airflows over the plane wing to improve aerodynamics. We can simulate the drag on a car to improve performance and also efficiency. Have a smartwatch? You can simulate how every component works for consumers like me and also for the most serious athletes. We can simulate the bubbles in champagne. And yes, souls matter. And yes, they are engineered too. We even have customers using our technology to engineer the perfect wave while optimizing water consumption. So far, so good. We've built the digital twin, optimized it. What matters now is, can you actually produce it? And this is where software-defined automation, the second building block of the industrial metaverse, comes in. It is about combining the real and the digital worlds. It's about what happens on production machines, what happens in factories. 1 in 3 factories globally runs on Siemens controllers. These are little boxes with software and hardware in them, like mini brains all around the factory. These mini brains tell the machines what to do. So they synchronize in a beautiful choreography, millisecond by millisecond. These controllers are called PLCs, programmable logical controllers. Here's the issue. Today, PLCs speak industrial programming language. So if you want to talk to them, you need to learn this exotic programming. It's time for a revolution in factories. That's why we are launching the next generation of industrial controllers, virtual PLCs. In a factory for the automaker Audi, we will moving hundreds of PLCs into one rack. 100 virtual controllers instead of 100 little boxes. So you can run the small private local cloud from miles away while still fulfilling real-time requirements. You want to ramp up production? A few virtual controllers to be added with a few mouse clicks. You want to run software updates? One click for all of the controllers in your factory at once. And you want to reprogram your machines? You don't even need to learn an industrial programming language. You can use any modern software code. And it's not just factories. Everywhere you look, energy grids, office buildings, trains, they are all being operated and optimized by PLCs. Of course, you can't just have good brains, you need to feed them good data too. And that brings me to the third building block of the industrial metaverse: data and AI. Any idea how much data a highly automated factory generates? Well, it's more than 2,000 terabytes per month. That's the equivalent data volume of about 500,000 movies. 500,000 movies every month. And I tell you, no plant manager will ever upload all this data to the cloud. The industrial metaverse, though, is a space where this data becomes information, where raw numbers become actionable insights, with the help of edge devices and AI. Edge devices collect all the information on the shop floor and recognize important patterns. They filter the data and forward only what's important. AI allows you to access all the knowledge in your company so you can better engineer the solutions you need. Generative AI, large language models, let you talk to your machines in natural language as if they were human. A few weeks ago, we announced a great innovation. Together with Microsoft, we have built the Siemens Industrial Copilot. This acts as your programmer and revolutionizes the way you operate your machines. Well, to accelerate the pace of software development across industries, we are continuously expanding our ecosystem. And tonight, I'm proud to announce a new solution we were launching. Together with Amazon Web Services, we will make the power of generative AI accessible to all by integrating it into our low-code development platform, Mendix. Using low-code platforms such as Mendix, anyone can create computer code. No need to spend years learning a programming language. You just drag and drop the elements you need, but integrating AI functionality in your low-code programmed application has remained a challenge. Not anymore. Now, for the first time, you can pick a generative AI model and add it to your application with just a few clicks. So, anyone, programmer or not, can enrich your low-code or even no-code apps with AI, making them smarter than ever before.
I know that for most of you, when you hear metaverse, you think it's where you go to escape the real world. For us at Siemens, the metaverse, actually the industrial metaverse, is where you go to make the real world better. And Roland told you, look, we use digital twins to do that. So I brought you a digital twin. I actually brought you a digital twin of a boat, and you see where's where. But you can also see beautifully how it actually would feel like. You would actually see how does it look like at night, how would it look like if there's a storm. You can simulate everything, and it looks really, really great. Now, if I speak about looking great, the industrial metaverse is using a technology you might recognize from movies like Finding Nemo, right? The company Pixar, which transformed the way we enjoyed entertainment, did this by creating a 3D standard for movies, which were called USD, the Universal Scene Description. So USD allows engineers and artists to work together to make a movie. Now what happened is Pixar introduced this standard for movies. Now we are extending it into industry. So I'm very excited to announce that we are joining the Alliance for Open USD. You can clap, yes. So why is that important? Because engineers have access to beautiful 3D images, as you saw, and it has the information of physical and mechanical data. They can experience how much an object weighs, how they perform, just as they would be in the real world. So that's super important. So the important part is to make this industrial metaverse work, you cannot do it alone. Multiple companies have to work together. So I brought you a couple of other examples. So this is something we've done with NVIDIA. So with NVIDIA, we came up with the capability to build the next BMW plant in the metaverse, in the industrial metaverse first. We work with Microsoft to optimize with AI the factories in terms of better automation. We work with Amazon Web Services to put the data into the cloud and make it more scalable. So you get where I'm going. It's all about collaboration. So tonight, I'm honored to announce a world premiere. It actually involves the company which changed my life when I was 14. A company that made music portable, the Walkman, right? It changed my kid's life also with the PlayStation, and by now most of you know which company it is. Yeah, Sony. Sony shares our view that technology powering the gaming industry can be used actually in the industry space too. So together, we're going to take all of you into the industrial metaverse. And to show you on how it's done, let me introduce and welcome our partner from Sony, Yoshinori Matsumoto. Yoshi, can you come in? So Yoshi, that looks great. What is it?
This is our brand new head-mounted display for 3D content creation.
What do you use it for?
Okay, please take a look at the video.
Okay.
First, we had manual drafting, then 2D computer-aided design, then 3D. And today, Siemens and Sony are introducing the next generation of industrial design, immersive engineering. Thanks to the combined power of Sony hardware and Siemens software, immersive engineering will make industrial design immersive, intuitive, fun for designers and engineers everywhere. That's right. Just put on this new head-mounted display and you'll be instantly transported to a virtual world nearly indistinguishable from the physical one. Attach the controller to your finger and you can manipulate your designs in an entirely organic way, just as if you were playing around with an object in your hands. But of course, you're not just playing around. You're in the industrial metaverse. You're using accurate engineering data so you can prototype virtually, efficiently, sustainably. And you can do it in collaboration with colleagues all around the world, leveraging your team's collective knowledge seamlessly in real time, working together to realize better, more purposeful, more transformative innovation. It's the tight integration of Sony's hardware and Siemens software that makes this possible. that lets you experience your digital twin in a fully immersive, incredibly natural way. So you can validate your designs faster than ever with far fewer resources. Just like you see here in the cockpit of a Formula One car. Instead of just experimenting with a digital twin of the race car's steering wheel, the design and engineering team at Red Bull Racing experiences the steering wheel in a comprehensive virtual environment in the industrial metaverse. They leverage data from software to place the wheel properly. They interact in real time with CAD data. And then they transport themselves to a virtual racetrack where they can validate visibility, check eye lines, and perfect their work before they launch it in the real world. This is immersive engineering. It is the future of design and manufacturing. It's what will let you step into the industrial metaverse